Hey, Algebra 1, we just finished our mid-chapter test, and we're moving on into the rest of Chapter 6. Today we're going to be talking about polynomials. We've actually talked about the word monomial before. We said that it's a number, a variable, or a product of the two together. So I could have a number like, let's say, 8 is a number. I could have a variable like y. I could multiply those together because that's what product means. So I could multiply 8 times y. I might want to multiply a squared times b cubed. Again, that's a product. I could have 1/2 times c d to the 4th. Again, this is a number, so it's a constant being multiplied times variables. But monomial means you have one term. Term means that you do not see addition or subtraction here. So what we're seeing is either something all by itself, like the 8 or the y, or we see a product of numbers and variables. Those things are joined together by multiplication. So they're not joined together by addition or subtraction. They're joined together by multiplication. All right, degree of a monomial. This is new to us. It says the degree of a monomial is the sum of the exponents of the variables. Sum means we're going to add. So what are we adding? We're going to be adding the exponents of the variables together for that monomial. So if we look at number 1, we're looking at just the variables, and we have both x's and y's. What are the exponents of those two? Well, we have a 4 for the x, and we have a 2 for the y, and according to the directions, we are going to add those exponents together. So 4 plus 2 is going to give us a degree of 6. Now if we look at example number 2, there's only a b. There's not multiple variables there. There's just a b, and what is its exponent? Its exponent is a 3. There's nothing for me to add that to because there isn't another variable in the problem, so that degree is just a 3. Now let's look at number 3, because number 3 is different. Notice it doesn't have any variables at all. Matter of fact, you could say it has 0 variables, and so its degree is 0. So if there are no variables, if it's a constant, that means it's a number, just a number. It doesn't change because there's no variable there, then its degree is 0. Example 4, we've got g and h. Let's look at their exponents. We have an exponent of 2 for the g. What's the exponent for the h? It's a 1. So we're going to take the 2 and the 1, we're going to add those together, and we're going to get a total of 3. So our degree is 3. Number 5 is a constant. It doesn't have any variables. That means its degree is 0. And then lastly, number 6, all we have is the variable p, and its exponent is 1. And so that means that the degree is just a 1. All right, a polynomial, it says, is a monomial or a sum of monomials. So we're either going to have a single term, that's what monomial means, single term, or we're going to be adding several single terms together. Now we have some specific vocabulary words. So monomial means you have just one term. A binomial, bicycle has 2 wheels, binomial has 2 terms. A trinomial, think of a tricycle, it has 3 wheels, so a trinomial has 3 terms, and anything that has more than 3 terms, we just call it a polynomial. So monomial means 1 term, binomial means 2, trinomial means 3, and anything higher than that is just a polynomial. Here it says that polynomials are usually written in standard form, and for us what standard form means is that we're going to be arranging our exponents in descending order. So in other words, we're going to start high and we're going to end low. So starting with the highest exponent and then ending with the lowest exponent. So here it says, for example, x squared plus 4x minus 3 is in decreasing or descending order. Looking at your exponents, x to the 2nd power, x to the 1st power. This one doesn't have an x at all. That's like having an x to the 0 power. So notice it went from an exponent of 2 to an exponent of 1 to not even having an x at all. Now, sometimes we do write answers in ascending order, which is going to go the opposite way. You're going to start with your low exponent and you're going to work your way high. But if it asks you specifically for writing it in standard form, you want to start high and end low. All right, so these first four examples simply say, determine whether this is a polynomial. So in other words, can you determine if it's a monomial or a sum of monomials? So let's look at number one together. And it says 7x squared y cubed plus 6xy minus y to the fifth. All right, so something that might jump out at you right away is this minus sign. So you might say, no, this is not a polynomial. But if you remember, subtraction means add the opposite. So this is the same thing as having plus a negative y to the fifth power. So we do indeed have sums. We are adding those terms together. So now let's look at each of those three terms and determine if what we have is a monomial. Now remember the definition of a monomial. It could be a number, a variable, or a product multiplication of the two together. So here we have numbers, we have variables, and they're all being multiplied together. So that is definitely a monomial. Here we have the number 6, we have a variable x, we have a variable y, and they're all multiplied together. That's a monomial. And back here we have a negative y to the fifth power. That's variables. It works. So this is definitely a polynomial. All right, let's take a look at number 2. So we have 2/3 g squared minus 1. That would be the same thing as having 2/3 g squared plus negative 1. So we have a sum of two different things. So this might be a binomial if each of those are monomials. Let's check. So this right here, we have a number, 2/3, that's being multiplied times a variable. So that one works. That's a product of numbers and variables. Back here, we just have the constant negative 1. So remember our definition. It could be just a constant, just a number. So yes, this one is going to be a polynomial. Let's look at number 3. We already have a sum, so we're starting off good. Let's look at the first term. We have negative 5 over h to the third power. Do you guys remember what a fraction bar means? It represents the operation of division. So here we don't have a product of a number and a variable. We have a quotient of a number and a variable, and that is not okay for a polynomial. It has to be a product. So we're going to be able to say that this is not a polynomial. And the reason that it doesn't work is because there was division occurring between the number and the variable. Last one, example 4, it just says a 7. 7's a constant. Our definition of a monomial is it could be a constant, so this one absolutely works. So hopefully you have a pretty good understanding of that definition. All right, we've talked about degree of a monomial. That means how do you find a degree of just one term? Here we're going to have a definition for a degree of a polynomial, which means maybe we have several monomials that are joined together using addition. So it says the degree of a polynomial is the greatest degree of its terms. So in other words, if you had 4 terms, whichever one of those had the highest degree, that would be the degree for the entire polynomial. So let's take a look at number 1. We have 2 terms, this one right here and this one right here. Let's start with the first term. Remember, to find the degree of a monomial, you want to find the sum. In other words, we're going to add the exponents of the variables. So we have g to the 4th and h to the 3rd. That means 4 plus 3, we're going to get a degree of 7 for the first term. The second term, we have g to the 2nd power, h to the 9th power. So again, we're going to add those exponents together. So the degree of that term is going to be 11. Well, this says to find the degree of the polynomial, you're going to take the greatest degree, the biggest one, which is bigger, 7 or 11, obviously 11. So the degree of that entire polynomial is 11. So whichever one is the biggest, that's going to be the degree of the whole entire thing. So here we have 1, 2, 3, 4 terms. Remember, this is like plus a negative 2/3 x, and this is like plus a negative 15. So let's go through and identify the degrees of all of them. Let's start with this first one. Notice that it just has a variable of an x, and its exponent is a 3, so it has a degree of 3. Second term says 4x to the second power. It just has an x, and its exponent is a 2, so that means its degree is a 2. Then we have negative 2/3 x. What is the exponent of that x? Well, it's just a 1. Remember, if it doesn't have an exponent there with a variable, it's understood to be a 1. And then this last one is a constant. What do you notice about it? It doesn't have any variables. That means its degree is 0. Well, which of these is the greatest? Obviously 3. So the degree of that polynomial is going to be positive 3. So hopefully that makes sense and gives us extra practice with finding degrees of monomials. All right, so let's go over some vocabulary. We have some polynomials. We're going to find out the vocabulary used to identify them by their degree. So we have to be able to first find their degree, then we're going to identify vocabulary, and then we're going to talk about what word could we use based on how many terms does that polynomial have. So let's start here. We have just a 6. So remember degree. We want to look at the exponents of the variables, but we don't have any variables, so its degree is 0. If you don't have any variables at all, and I use this word all the time, it's called a constant. We've already heard that word today in this lesson several times. Constant means there's no variable, it's just a number. And then identified by number of terms. How many terms is that? Just 1, so we're going to call it a monomial. All right, let's take a look at this next one. 3x plus 1. To find the degree, we have to find the degree of each term. So let's look at the first term, 3x. What's the exponent there of the variable? It's a 1, so the degree is 1. Then we have just a number 1. What is the exponent of its variable? It doesn't have a variable, so its degree is 0. So remember, whichever one is the largest is going to be the degree of the entire polynomial. And that's going to be a 1 because 1 is bigger than 0. Well, what word can we use to describe that? Well, this is going to be a word that you're going to be very familiar with because we have talked about this for the majority of the year. This is going to represent a linear function because it could be rewritten in the form of y equals mx plus b. When you have x raised to the first power, that's a linear function. And this has 2 terms, and that means we're going to use the word binomial. All right, next one. Here we go. Negative x squared, positive 2x, and a negative 5. Those are our 3 terms. What's the degree of the first one? It's going to be a 2 because that x has an exponent of 2. What's the degree of the middle one? It has a degree of 1 because its exponent of x is a 1. And what's the degree of this last one? It's a 0 because it doesn't have any variables at all. And the largest of those is a 2. Now this word is going to be new for you. This is called a quadratic. So when your highest exponent is a 2, when your degree is a 2, that's what we call a quadratic. So we're going to be getting into quadratics throughout the remainder of this chapter and in the next chapter. You're going to begin to hear that word a lot. And this had 3 terms, and so that means this is going to be called a trinomial. All right, last one. We have 2 terms. This first one right here is going to have a degree of 3 because the exponent of the x is a 3. The second term is going to have a degree of 1 because its exponent of the x is a 1. So which one's higher? Obviously 3. Here's another new word for you. When you have something raised to the 3rd power, and that's the highest exponent, we call that a cubic. And because it had 2 terms, we're going to call that a binomial. So vocabulary that you want to start becoming aware of, you want to know constant, linear, quadratic, and cubic. You also want to know monomial, binomial, trinomial, and if you were to have 4 terms, or 5 or 6 or 7 or 10 or 57, you would call that a polynomial. All right, so here we're going to arrange terms so that the powers of x, so we're looking at the x's. If there's another variable there, we don't care. We're just going to look at the x's. We want those powers, those exponents, to be in descending order. Remember, descending order means you want to start high and work your way low. All right, we're going to start with our highest exponent. We're going to work our way low. So number one, we have 20x minus 5x cubed minus 7x squared plus 4x to the fourth power. So just as a reminder, remember a polynomial means a sum of monomials. So real quick, I'm going to turn this into a sum. So I'm going to have 20x plus negative 5x cubed plus negative 7x squared plus 4x cubed. So I have a sum of 4 different monomials. And I'm going to start with the highest exponent, which in this case is going to be the fourth power. So at the beginning, I'm going to have a 4x to the fourth power. So I have used that one already. Which exponent is going to come next? The 3. Now notice that what's with it is that negative sign. So I'm going to write minus 5x cubed. Notice that sign is sticking with the 5. So it has to come down with it. So I've used that term. Now I'm going to look for the next highest exponent, which is going to take me to a 2. This one right here. Notice it also has a negative, so it's going to be minus 7x squared. And then that's going to leave me with this. Now what happens if there's no sign in front of it? Well, that meant that it was positive. And what sign represents positive better than an addition sign? So we're going to put plus 20x. So you'll notice that whatever sign is in front of it is the sign that stays with it. It's stuck to it. It's joined to it. Don't separate them. All right, we're going to do the same thing for number 2. We're going to start high and work our way low, but here's what I want you to keep in mind. We're only looking at the x's. This one has y's in here too. We don't care about them because the directions say that we just want to look at the x's to determine the order. So let's look at what we've got. We're just looking at the x's, so I'm going to underline those. I have an x to the second power, x to the third power, x to the fourth power, and back here I don't have any x's at all. So I'm not looking at that 5. I'm just paying attention to the fact that there are no x's there. Which x has the highest exponent? That one has a 4. So I'm going to have positive 6x to the fourth power. How did I know it was positive? Because it had a plus sign in front of it. All right, what comes after 4? 3. Do we have one that has an exponent of a 3? Right here we do. So I'm going to put minus 12x cubed y squared. Notice I put the minus with it. That sign is joined to that. Sorry. All right, then after 3 comes the 2 right here. Again, there's nothing in front of it, but it's positive, so I'm going to put a plus sign. So plus 24x squared y. And then at the very end, I'm going to put this last one. And you might be wondering, why does it go at the end when its exponent is a 5? That 5 is for a y. There are no x's there. Remember, we're looking at x's. So it's kind of like there's an x to the 0 there because we don't have any. So it's going to go back here at the end because it does not have any x's at all. It's kind of like an x to the 0. All right, so this next one we're going to go in the opposite direction. Here we're going to go ascending order. So we want to go low to high. Again, we're looking at powers of x. So we only care about x's. We don't care if there's another variable there. All right, the first one is going to be pretty easy because there are nothing but x's. So let's look at what we have. We have an x to the second power, x to the fifth, x to the first, x to the third. What do you notice about the 15? It doesn't have any x's at all. It's like it has an x to the 0 power because it has 0 x's. So if I'm going to start low and end high, guess what's going to come first? That 15 because it didn't have any x's. So I'm going to put that positive 15 up at the front. Notice it's a positive because it had a plus sign there. Next would be the first power. So I'm going to have minus 18x to the first power. Then I'm going to move up to 2. So I'm going to have minus 12x squared. Then I'm going to move up to 3. So I'm going to have minus 6x cubed. And then 4 would come next, but there isn't one. So now I move up to 5, and I get plus 11x to the fifth power. So this one doesn't have any x's. It has 0 x's. This has 1x, 2 x's, 3 x's, 5 x's. So we went from low to high, only looking at x's. which is exactly what we're going to do for this next one. And the last one, so let me underline real quick the x's. This is an x to the first power. This is an x to the fourth power, x to the third power, x to the fifth power, x to the second power. And we're going to start low and work our way high. So if we're starting low, we're going to start with the one that has x to the first power. So negative 8x y to the fourth. Then we want to move up to the second power, which is right back here. So minus 6x squared y to the sixth. Then we're going to move to the third power, which is the one right in the middle, minus 5x cubed y squared. Then we're going to move to the fourth, right there, plus 9x to the fourth y. And that leaves us with one more term that has an exponent of 5 right here, plus x to the fifth. So again, 1, 2, 3, 4, 5. So we went low to high for powers of x. So that takes care of the notes for 6.5. Your homework, if I remember correctly, is in the book, check Ren Web. And if I remember correctly, it's odd problems. So be checking your answers so that you can know what you need to ask me for help for. Please make sure for some problems, maybe like some problems this doesn't really require a lot of work, and I understand that. But in this chapter, we are starting to get into problems where I'm going to need to be seeing work. So keep that in mind as you're turning in homework assignments, taking pictures, sending them in, and I'll see you in the next video tomorrow. Bye.